Hey everyone, welcome back to my channel. So in this lecture, we are going to look about the binary search. So basically, we'll be given an array and a target element as well. So we need to find where the target element is present in that array. If we are given 4, the index of 4 is 3. We need to return 3. If it is something like 8, the element is not found. We need to return -1. Let's see how can we do it with the help of binary search. So let me take an integer answer and I initially set it to -1 and just return answer, because if the element is not found I need to return -1. So I have just initially set it to -1. Now you need to understand how binary search works. Binary search works by dividing the array into two. So we need two things. One is start and another one is end, to specify the starting index and ending index to limit those regions, right? We are splitting into two. So we are dividing them. For that we need two variables, start and end. So let me declare int start, comma end. Okay, what is my start value? Initially my start value is the first one. So what is its index? It is 0. And what is my end value? End value is the last one. So I could use this formula, array dot length. It just gives the length of the array, but the index is -1. So array dot length -1. This is going to be my end. See, while my start is going to be here, my end is going to be here. So how many times I'm going to run the loop while my start is less than or equals to end? Oh, let's take it as S and E. Okay, while my start is less than or equals to n. Now I'm going to take my middle value. Int mid is equal to start plus n divided by 2. So I'm actually going to make comparison with this mid only, because I will divide this and take this as the middle element as 3. I will be comparing 3 with 4. If 3 is greater than 4, sorry, if 3 is equal to 4, no, it is not. Then I will check whether 3 is greater than 4 or not. If it is greater than 4, then I will check in the left hand side. If it is less than 4, I will check in the right hand side. So be clear with one thing, that you could use binary search only in case of sorted arrays, because we are having a check right greater than or lesser than. Only it would be possible only if it is a sorted array. Okay, I have created my middle element. So what are the three conditions? Just try to put those conditions in code. That's it. If my array of mid, that is my element at the middle index, is equal to my target, what I need to do? I just need to say, oh, not return. I just say answer is equal to m. Answer. My answer is going to be that index, middle index m. Okay. If it is not true, else if, what we need to say, array of middle is greater than my target element, then what I need to do? See one thing. This array is greater than my target. So let me take it as 2. This 3 is going to be greater than 2. Then what I need to do? I need to check in this left hand side. How I'm shifting this? Start is not going to change, but my end is coming to the value that is previous the mid. So I just say end is equal to mid -1. Now I have changed my region. Okay. Okay. It is also not true. Then what I need to do? I need to put an else condition that my start is going to middle plus 1. How? Take it as 4. 3 is less than 4. What do we need to do? We need to check in this right hand side. So I will rename my start to this middle plus 1, 4. Okay, I think this works. Let's take an array. Int array is equal to 1, 2, 3, 4, 5. And my target is going to be, say, 2. Sort binary search my array and target. Let's try running it. Okay. I have forgot to add this break statement over here, because if the element is found over there, then there is no need to check in other things, right? In the linear search also we added a break statement, because if the element is found we need to break that, so we need to add the break over here. Now if we run it, it just gives 1, because position of 2 is first index. What if I give 5? Good, it's working. 4. What if I give something like 10? -1 is being written. So that's all about this binary search. It's very simple, that we are going to give will be given an array. We are just going to break them. If the middle element is my answer, just return them. If it is greater, check in the left hand side. If it is smaller, check in the right hand side. What is this complexity? So in case of time complexity, you need to be very much clear with one thing, that whenever we are doing some sort of things like dividing, it will be taking log times complexity. Log of n. N is the number of elements. If there are 10 elements, it will take log 10. In the base, we will be saying 2, because we are dividing into two halves, right? So it would be like log 2n. So generally we used to say log n times of complexity. If you are dividing by 3, it will take log base 3n. So we are dividing into 3, but here we are dividing by 2 only, no? So it checks log n complexity. In case of linear search, it takes a big O of n. It's also big O of log n complexity. Big O of n times complexity, because you are iterating through it, entire element you will be checking one by one by one. Here you are not checking every element, you are just taking that middle element, comparing it with, if it is not true you will go over here, if it is not true you will go over here, and just ends. If it is end, you just end it. So that's it. That's all about this. Hope it is clear. Thank you for watching.